In this video, we are going to look at the science paper 1 for the year 2018. And this paper was written by the internal candidates. Now, also for those that are looking for biology, mathematics, English, and also the science, the one I'm looking at here, we have you covered. So you can just search for whatever that you are looking for. Then let's look at the first question for this paper. Now here, the first question is convert 2 GB, which is 2 gigabytes to standard units in bytes. So the first thing that we are supposed to do is, first we need to look at how many bytes makes 1 GB. So 1 gigabyte is equivalent to 1 billion bytes. So here we have 2 GB here. Then X. So the concept here is whenever you are converting from gigabyte to bytes, you just multiply by 1 billion. So we're going to get 2 billion bytes. So this is our answer here. So we can see that our answer is D. Now we can move on to question 2. The diagram shows a micrometer screw gauge. Okay, so then what is the reading shown in the micrometer? So the first one, we need to look at our main scale here. So what is the reading on the main scale? So we need to count 0. We have 1, 2, 3, 4, 5, 6. Now this one represents a 0.5. So if you have this smaller one before this vertical line here, so we are going to say under the main scale we get it's 6.5 millimeters. Then after that we are going to look at the vernier scale. The vernier scale is just the scale that is movable. Then from there, our key point is our focus under the vernier scale. We need to look at this calibration here. So if you look at the number before this is 10, so 10, this is 11, 12, 13. Now under the vernier scale, whatever the number that you get, you multiply by 0.01. So it's 13 times 0.01. So if you multiply 13 times 0.01, you get 0.13. Then our final answer, we are going to add 0.13 plus 6.5. So 6.5 plus 0.13. So I'm getting 6.63 millimeters as my final answer. So my answer is C here. So that's what you're supposed to do. Then we move on to question 3. The diagram below shows a distance time graph for a moving object. So in our y-axis, we can see that we have the distance in meters. Then in the x-axis, we have time in second. Now, the question is, what physical quantity does the slope of the graph represent? So, if we are to find the slope, let's consider this is our point A, then we'll consider this is our point B. So, from point A, if we are to take the coordinates, this is 0, 0. Then for B, we can see that our x is 4. So, this is 4, 20. So we'll say x1, then we'll say y1, x2 here, y1, then we have y2. After that, let's find the gradient. So the gradient is y2 minus y1 over x2 minus x1. So our y2 is 20, this number here. So it's 20 minus 0 over x2 is 4 minus 0. Then our m is equal to 20 minus 0 is 20. Now remember that in y-axis we have distance in meters over, then for the x-axis we are going to say 4 minus 0 will get our 4 in seconds. Then if we divide this, will give us 5 meters per second. So this gradient here is same as we are solving for speed, because we know that speed is equal to distance over time. Now remember, if the y-axis were to have displacement, then this would have been velocity, because velocity is equal to displacement over time taken. So whenever you are dealing with distance here, remember that the physical quantity that you are calculating is speed. So the answer here is speed, because speed has to do with the distance divided by time, and speed is a scalar quantity. Under the speed, we don't mention the direction, we just only look at the magnitude. So we move on to question 4. Question 4, what happens to the mass and weight of a liquid in a container when the container is moved from Earth to the moon? So if we are to define mass is just defined as the total amount of matter. So it's just total amount of matter in a substance. Now the question that we would ask ourselves is, does mass change? If we are to move an object from Earth to the moon, will the mass of that particular object change? The answer is no. The mass does not change. So here it's we need to look at C or D, because we know that the mass will stays the same. Now what of the weight? So if we look at the weight on Earth, the mass, if for instance the mass was to be measured as 2 kg, then if we put our 2 kg here times 10, which is we are getting 20 newtons under on Earth. Then if we look at the weight on moon, this will be 2 kg, since we said mass will not change. Then the gravity is about 1.6. So if we multiply 1.6 times 2, we are getting 3.2. So we can see that the weight differs, and the weight on the moon decreases compared to the weight on Earth. So our answer here is D. The mass stays the same, the weight will decrease, since the gravity on moon is less than the gravity on Earth. Then we move on to question 5. The forward force of a bicycle traveling at a constant speed along a level road is. So the point here that you're supposed to look at here is the constant speed. So if maybe for instance, if we are to have a picture of a bicycle here, so don't mind my drawing here. So the point is, the key point is we have the constant speed. If this person is moving in this direction, remember that this person will experience a friction force, and the friction force is the force that opposes motion. So there is a force that is trying to oppose the forward motion. Then the force that is making this bicycle to move is the force that is being applied by the individual here. Now the question is, the forward force of a bicycle traveling along the level road is. Now here this question is same as we are looking for the resultant force. So let's look at the formula. So we know that force is equal to mass multiplied by acceleration. Now whenever we have a constant speed or constant velocity, remember that the acceleration is always 0. And we know that if we are to find the force given the mass of this person, let's say 5 kg, then if the acceleration is 0, we can see that here we are going to have the force of 0. So for an object or for something that is moving with a constant speed, the acceleration is 0. And whenever we have the acceleration of 0, then the resultant force is also 0. So the key point is the forward force must be equal to the friction force, so that if we have the forward force of 20 newtons, we are going to have negative 20 newtons for the friction. So that if we are able to calculate the resultant force here, we are going to get a 0 for us to get the acceleration of 0. So A less than the friction force, then greater than the friction force, in equilibrium with the friction force acting the same. So the answer is C. For us to have an object moving at a constant speed, the forward must be equal to the backward force. So you have to be careful whenever you are dealing with a question like this. So the key point is you just have to look at the point. Is there the point about the constant speed or constant velocity? So whenever you have that, remember that the forward force or resultant force will be 0. Then we move on to question 6. The diagram shows a uniform plank in equilibrium when two weights are hung on opposite sides of the pivot. Okay, so we can analyze here. Now the question is, what is the size of weight F for this to balance? So remember, this moment here, we'll consider this one as moment 2, must be equal to this moment here for this setup to balance. So we'll say moment 1 must be equal to moment 2. Then we'll say force 1 times distance 1 is equal to force 2 multiplied by distance 2. So the force 1 is this one here, which is a 500 newtons times the distance is 30 centimeters. Then is equal to force 2 is what we are solving for. Distance 2 is 50 centimeters. So we have a 50 centimeters. So 500 times 30, we get 1000. This should be 15,000. So 15,000 Newton centimeters is equal to 50 centimeters force. So we need the number here that we can multiply by 50 to get a 15,000. So that's a concept here. So by what number can we multiply by 50 to give us a 15,000? So because we need to have a 15,000 on the left side and also on the right side. So for us to solve for that number, we divide by 30. We do the same here. So that we cancel, we have this force 2 is equal to centimeter cancels. We cancel this 0. We cancel this 0. So 5 into 5 is 1. 5 into 15 is 3. So the answer is 300. Because we know that if we multiply 300 times 50 here, will give us a 15,000. Then here we have a 15. So this now balance. So the answer here is C. We move on to question 7. A man pushes a box along an inclined plane by a 300 Newton force as shown below. Then, okay, now let's look at the question. So the question is, how much work is done by the man in pushing the box? So here we are going to have two works done. There is one against gravity. One against gravity is the work that is we can consider here. Then there is also this now in pushing. So since we are dealing with in pushing, and we know that work is equal to force multiplied by distance. We know the force that was applied is a 3,000 newtons. Now since they have not given us a statement of the weight, the work against gravity. So therefore we need to find this distance, the one that is slanting, because that is the the work that was done here. So how can we find this distance? So we are going to use the Pythagoras theorem. So we'll say if this is our C, then we have A, we have B. So the formula for Pythagoras theorem is C squared is equal to A squared plus B squared. So C squared is what we are looking for. So this is a 90 here, so we are looking for hypotenuse here. So what's our A? Our A is just 4 squared plus our B is 3 squared. So if we square 4, we get 16 plus 9. Then what is the sum of these two numbers will give us 25. Then we take the square root for each side. So C will be equal to 5. So this means that the slanting distance is 5 meters. So for this person to move from here up to here, this person covered a distance of 5 meters. So we'll say work done is equal to force. The force is this one, 300 times 5. So if we multiply 300 times 5, we get a 1,500 newtons. Then, so this was the work that was done here. So let's look at that. So we have 1,500 newtons. So our answer is C. But if the question was to find the work done against gravity, then we would have calculated, would have multiplied 300 by this distance, which is would have gotten our answer to be 900. And you have to be careful because we have these two answers, but the question is now it's not against gravity, so you just have to consider the distance that is slanting. Okay, so now we move on to question 8. Which of the following graphs shows the relationship between volume and the Kelvin temperature of a fixed mass of a gas at constant pressure? So here, this is the Charles law. Now, under the Charles law, we know that the pressure remains what? Constant. Now, what happens? Let's say, what happens if we increase the temperature? Does the increase in temperature helps the volume to decrease or to increase? So you'd find that if you increase the temperature, the particles will gain the kinetic energy. As a result, the particles will start to move far apart from each. As a result, the volume increases. So the relationship between temperature and volume is these two are directly related. So we are looking for a graph that is giving us a direct relationship. So our answer is A. Because for a direct relationship, we need to have a linear line, a straight line here. So this is our answer here. Then we move on to question 9. The diagram below shows a water wave. Then what is the wavelength of the wave? So the wavelength is just the distance covered by one complete cycle. So let's look at we need to draw a straight line here, and we know that the line that I'm drawing here, this is considered to be a rest position. So if we start from here, this point we are getting a one wave, then here we are getting 2 waves, then here we have 3 waves. So we can see that the total number of waves that were here is the total number were 3 waves. So 3 waves will have 20 centimeters. Then the question is, if 60 centimeters is the total distance for 3 waves, how much of that 60 will be for 1 wave? So what we are going to do is, for us to find the wavelength, we'll say the total distance, which is 60 centimeters, then we divide by the total number of waves, which is 3. Here, if you divide, you find the answer to be 20 centimeters. So this means that from here up to there, we have the distance of 20 centimeters. Here up to here, another 20 centimeters. then we have 20 centimeters. So in total, we can see that we are getting this number of 60. So the answer is just A here. Okay, so now we move on to question 10. The diagram below shows a ray of light incident on a plane mirror. So incident ray, normal line, mirror line. So if the mirror is rotated clockwise through an angle of 10 degrees, which diagram correctly shows the angle through which the reflected ray rotates? Now, this rotation has nothing to do with the angle of reflection and angle of incidence. So let's try to, if we can complete this ray diagram here. So the reflected ray will be here. Then we can find the angle of incidence here. The angle of incidence, if we have this angle, this is the angle between the incident ray and the boundary. So how can we find the angle of incidence? We subtract 30 from 90. So here we are going to get 60 as our angle. Then if this is 60, also here we are going to get 60, because we know that the angle of incidence is equal to the angle of reflection. Then here we are going to get 30. Now let's look at what is the value of this rotation. So how much can we, so what is the question? Which diagram correctly shows the angle through which the reflected ray? So the whole thing is about angle of reflection. So the key point, we said if here we have 60, also here we are going to have 60. So the answer is C. Then we move on to question 11. What happens to light as it passes from glass to air? So this is like refractive. If we have two media, the first one is we have glass. This is our glass. Then we have the medium air. So let's draw our normal ray. So we are looking at the ray of light moving from the glass into air. So when exiting the glass, this ray of light will bend. The first one will bend away from the normal ray. So that's what happens whenever our light moves from a more denser medium, into a less denser medium. Then what happens to the speed? We know that the refractive index of a glass is greater than that of air. So the light travel at a slower speed in a glass compared to air. So whenever light moves from the glass into air, the speed will increase. So the speed will increase. Now if the speed increases, what happens to the frequency? Frequency does not change. That is for frequency. Then what of the wavelength? The wavelength is related directly proportional to the speed. So if the speed increases, so is the wavelength. So that is the answer that we are looking for here. So a wavelength increases because its speed increases. So this is our answer. Because for B, frequency decreases. No, the frequency does not change. C, frequency does not change. Wavelength decreases because its speed decreases. No. So the answer is A. Then question 12. A sound wave of frequency 400 Hz travel in air at a speed of 340 meters. What is the distance from which the center of a compression to the center of the nearest refraction in the wave? So here the question is, we just want to find the wavelength. So how do we find the wavelength? So wavelength is equal to speed, which is velocity, divided by frequency. So the speed is 340, we have it, over the frequency is 400. So we can now do mathematics. So 340 divided by 400, I'm getting 0.85 meters. this was the distance. So the answer is B here. Now we move on to question 13. A bar magnet was broken into 3 pieces as shown in the diagram below. So what will be the polarity of the ends labeled E, F, G, and D, H? So if we are so this was how the magnet was before broken. So we have the north pole, which is this one, and the south pole here. So what happens if you break it? So the point here is, if this is the north pole, then here we are going to have south pole. If this is the south pole, let's look at the H. What's our H? Our H will be north pole. If H is our north pole, then this will be our south pole. Then here we have north pole. So let's look at E is south pole. F is north pole. So south pole, north pole, south pole, north pole, no. So south pole, north pole, north pole, south pole. Our E is south pole. Our F, north pole. Our G can't be. G can't be. So our E is the south pole. So between these two, then if this is our south pole, what is this one? So this one is north pole. If this is north pole, this is south pole. Then this is north pole. So the answer is B. So north pole, south pole. Okay, north pole I've seen. So that's our answer. Then question 14. A polyethylene. So this should be a polyethylene rod can be charged negatively by rubbing with a wool cloth. How does the rod gain its charge? By, so since it becomes negatively charged, substances become negatively charged by gaining. So it's all about gaining electrons, because the substance that gains electrons attains the negative charge, while those that gives or loses electrons attains the positive charge. So question 15, the diagram here shows a circuit. So what is the reading on the voltmeter? V2. So where is V2? So this is our V2 here. Then the voltage on V1 is 6 volts. Now let's look at the total volts. So let's look at the total volts. So the total volts that was produced is 9 volts. Then from 9 volts we can see that this 12 resistance uses 6 volts. Now this should be 3 volts, but let's first find the current. So know that current is equal to voltage over total resistance. So we have resistor 1, resistor 2. So total resistance RT is equal to resistor 1 plus C resistor 2. So it's 12 plus C 6, which is giving us 18. So if we are to find current, so voltage will be the total is 9 over 18. We know that this will give us 0.5. So the total current is 0.5. So here we have 0.5. Also here we are going to have 0.5, because the current is equal whenever a circuit is connected in series. So let's multiply 12 times 0.5. 12 times 0.5, we get 6 volts. This is how this came. Then we'll say 6 times 0.5, because we know that voltage is equal to current multiplied by resistance. So if our current is 0.5, then our resistance is 6, then we'll be able to get 3. So our answer is 3. The reason why I never wanted to rush into finding the answer to be 3, because we know that since the total is 9, if we subtract 6 from 9, sometimes you may find that resistor 1, this one, uses a certain amount of voltage, which is 6. Then you may find that maybe resistor 2 is only using 2 volts. Maybe there may be a remainder from the total produced. So the best way to be sure is you do the calculations. So we move on to question 16. If the electrical energy costs 2 kwacha per unit, what is the cost of running a 2 kilowatts heater for 3 hours? So we'll say cost is equal to power in kilowatts times time in hours multiplied by cost per unit. So power is already in kilowatts, so we just do the substitution. 2 times hours, 3 hours, times 2 kwacha. So 2 times 3, 6 times the answer is 12 kwacha, which is A. So 17, why is soft iron used in the core of the coil in the direct current motor? To A, prevent the core from spinning? No. B, prevent the core from spinning faster? No. Reduces the strength of the magnetic field? No. D, increases the strength. Because we know that iron is easy to magnetize and also to demagnetize, so that increases the strength. Then 18, the diagram shows a coil in magnetic field. The coil is part of a DC motor. Then what must be connected directly to J and K? In which direction will the coil rotate? So a DC is connected to, we call this slip rings commutator. Then the direction is this will move up, then it will go down. So the movement is like clockwise. So let's look at the multiple choice. So the answer is B, split ring commutator and clockwise direction. We can't have a counterclockwise here. Then 19, the symbol U23892 represents a nuclear notation for uranium. Which of the following gives the correct number of electrons and neutrons? So electrons, we just get the atomic number. So there are 92 electrons. Then for neutrons, you get the mass number, which is 238. You subtract 92. So 238 minus 92, I'm getting 146. So this means that there are 146 neutrons. So the answer is B. Which of the following equations shows a nuclear fission reaction? So fission, we are looking at breaking. Unstable nucleus breaks. As a result, we get a certain amount of energy. So here, the first one, we can see that these two join. So this is fusion. Then this is gamma radiation. Look at the mass number. The mass number is 46. Here 4621. So nothing happened. So this is a gamma radiation. Then C is also fusion, because these two combine to give us this one. So the answer is D. D is our answer. We can see that this uranium breaks to give us this one, and also 3 neutrons plus energy. So that's our answer. Then we move on to section B. Answer all questions in this section. Write your answers in the spaces provided on the question paper. So we have figure B1.1 and 1.2 below shows two tanks containing liquids M and N. Okay, we have this. Then we also have this. Now let's look at what is the volume of each liquid in cubic meters. So let's go back to our first. Let's go back to our first diagram. Okay, so we can see that this is length, breadth, then we have height. So what is the formula here? The formula is volume is equal to L times B multiplied by H. In some books you may find this to be width. It's the same. So this is the formula for a cuboid like this one. So the longest is 0.6 meters times 0.5 meters multiplied by the height is 0.4 meters. So let's multiply 0.6 multiply by 0.5 times 0.4. So I'm getting 0.12 cubic meters. So this is the volume for this liquid M. So let's find for liquid N. We can see that the base area is the same because the dimensions are 0.6 for length and 0.5 for width, but the height now changes to 0.2. So use the same formula. It's L times B multiplied by H. Length is still 0.6 times 0.5 multiplied by 0.2. So 0.6 times 0.5 times 0.2. So 0.6 times 0.5 times 0.2. This I'm getting 0.006 meters cubed. So these are the answers for question A. Now for B, what would be the mass of 1 meter cubic of liquid M? So let's go back to liquid M. So liquid M is this one. So this 80 kg is the mass for 0.12 cubic meters. Now the question is, what would be the mass if the volume is 1 meter cubic? So you know that 1 meter cubic is far much greater than 0.12. So how are we supposed to do? What is this question implies? So this question is indirectly asking us to find the density of this liquid M. Why? If for instance, let's just say density. We know that density is equal to mass over volume. If let's say we have mass as our 20 kg, then the volume, let's say we have 4 meters cubic. So we know that if we divide 4 into 20 will give us 5 kg per cubic meter. So this means that per 1 cubic meters there is this mass of 5 kg. So that was the question. So whenever you are trying to find the mass per given volume, just know that it's a density that you are calculating indirectly. So let's go back. We know that the volume, we have it 0.12, then the mass is 80 kg. So now let's do that calculation. So we know that density is equal to mass over volume. So the mass is 80 kg over the volume is 1.2 meters cubic. So 80 divided by 0.12. So I'm getting 666.66, which is 0.7 kg per meter cubic. So now you can see the point. So this means that per 1 cubic meters there is the mass of 666.7 kg. This is what it means. This answer can also be answered like this. So we know that if 0.12 kg, I mean meters cubic, has a mass of 80 kg, what would be the mass of 1 meter cubic? Here you cross multiply. So if we cross multiply, we know that here will be 0.12 kg, sorry, this should be meter cubic x, then 80 kg meter cubic. So we divide by this, also we divide by this. So if we cancel, we know that this will cancel. So 80 divided by this will still get the same answer. So it's 666.7 kg. So that is what the question is. Then for C, calculate the density of liquid N. This question is direct. So density of liquid N, what was the volume of liquid N? Liquid N has the volume of 0.06. Then the mass is 50 kg. So let's go back. So we know that density is equal to mass over volume. So the mass is 50 kg, the volume is 0.06 meters per cubic. So 50 divided by 0.6, so I'm getting 833.33. we are verifying here, so 0.3 kg per cubic meters. Also this means that per cubic meters of liquid N there is the mass of 833.3 kg. So this is what it implies. Okay, so we can now move on to question 2. So for question 2, we have figure 2.1 shows some of the forces acting on a car of mass 800 kg. Then we have the direction of motion. Then driving force is a 2,000 newtons. Total drag force we don't know. Then A, state the size of the total drag force when the car is traveling at constant speed. I gave you the point here. Okay, so what are we supposed to do? The condition is given. So if the speed is constant, if we have a constant speed, what is the acceleration? The acceleration would be 0. Why? Acceleration only exists if the speed is changing, either decreasing or increasing. For example, if you have a velocity time graph, whenever we have a straight line, there is acceleration. Why? The speed is changing. Whenever we have a horizontal line here, the acceleration is why? 0, because the speed is constant. Whenever this is moving down here, there is acceleration which is negative, the speed is decreasing. So the point is, when the speed is increasing, you get the positive acceleration. When the speed is reducing, you get a negative acceleration. But the point is, acceleration only exists when the velocity is changing. And we know the definition for acceleration. Acceleration is defined as the rate of change of velocity. So, if our acceleration is 0, what is the resultant force? So, what would be the net force? So, the net force, we know that net force is equal to mass times what? Acceleration. So, the mass is 800. Then the acceleration is what? 0. So, if you multiply this, we are going to have 0 Newton. So, how can we get this 0 Newton? We know that if the driving force is 2 2,000, then the total drag force should also be 2,000, but in an opposite direction. So this must be a negative. So here we'll just say negative 2,000 newtons, so that if we add these two numbers, we are able to get the resultant force of 0. So the point here is, the first point that I want you to have in mind here is, if this car or an object is moving at a constant speed or velocity, the acceleration is 0. When the acceleration is 0, the net force is what? Is also 0, because the relationship between acceleration and net force is directly proportional to each. So if the acceleration is 0, the net force is also 0. So you only have the net force in conditions where the car is changing its speed by either increasing or decreasing. So that's the point here. Now let's go to question number B. So if the driving force is increased, now you can now get the picture here. So this time the driving force is increased from 2,000, from 3 to 3,200. So since this time now the speed is increasing, this time we are going to have the acceleration, and if you are going to have the acceleration, we are going to have the net force. So the question is, find the resultant force. So resultant force is the net force. So the force increased to 3,200 newtons, then the drag force is still the same, so it's 2,000 newtons. So if we do the mathematics here, is 3,200 minus a 2,000. So I'm getting my net force as 1,200. If you have a net force, then we are going to have acceleration here. So I get the initial acceleration of the car. So we'll say now force is equal to mass times the acceleration. So if we divide by mass, we also divide by mass. So what is our acceleration? Acceleration will be force over mass. What is the force? The force is, you get the resultant, which is 1,200. Then you divide by the mass is given from the question. So the mass is 800 kg. So we divide by 800. So what is 1,200 divided by 800? So I'm getting 1.5 meters per second squared. So this is how you deal with a question like this one. Okay, so now we move on to question 3. Figure B 3.1 below shows an aeroplane flying at 120 meters above the ground. A box of mass 1.2 kg is seen falling off the aeroplane. So okay, then let's look at the first question. Calculate the weight of the box. So weight is equal to mass by gravity. The mass is given is 1.2 kg. Gravity is this number is given, it's 10 newtons per kg. So we know that this will cancel. Then our weight will just be, if we multiply 1.2 times 10, we get 12 newtons. Now for question B, what would be the kinetic energy of the box just before hitting the ground? So let's go back to our diagram here. So for us to find the kinetic energy, we need to have mass. Mass, we have it, is 1.2 kg. But the question is, do we have velocity? So we don't have velocity. So how can we find this answer here? So let's analyze this one. So we'll say, we know the distance from the ground up to where the aeroplane was is 120 meters. So what was the potential energy just before this box fell off? So we can find the potential energy. So we know that potential energy is equal to mass times height times gravity. So the mass is 1.2 kg. then gravity is 10, height is 120. So if we multiply 1.2 times 10 times 120, you get 14,000. So it's 1,440 joules. So that was the potential energy at this point. Now, if this object is now allowed to fall, what happens to the potential energy? We know that potential energy is just the energy stored in an object because of not moving or something that is stationary. So if this object starts to fall here, potential energy cannot be now, is no longer stored in an object that is moving. So what happens? The potential energy will be now converted into kinetic energy, because we know that kinetic energy is a type of energy that is possessed by an object due to its motion. So the potential energy will be converted into kinetic. So when this box covered half of the distance of 120, which is 60 meters, here at this point, the potential energy is equal to kinetic in terms of half of this. So at this point, the half of 1,440 has converted into kinetic. So what is half of 1,440? So if you divide by 2, you get 720. So at this point, kinetic energy, half of that kinetic energy is equal to 720 joules. If this object continues to fall down, by the time it is hitting the ground, all the potential energy has been converted into kinetic energy. So now at this point, we have the 1,440 into kinetic energy. So whenever you have a question like this one, where you only have the data that you can use to find the potential energy, and the question is indirectly asking you to find the kinetic, as long as the question is before or just after, as long as hitting the ground, the first step is find the potential. Then after you find the potential energy, you just have to say therefore. So here we'll say therefore kinetic energy is equal to 1,440 joules. So that would be the kinetic just before hitting the ground. Now let's go back to this formula for potential energy. So from the potential energy, we can see that we have mg h. Then let's look at what is the formula for weight. Weight is equal to mass times gravity. So what I want you to see here, for those that maybe you may have not seen it yet, is under the potential energy there is the weight of an object. So potential energy can also be calculated by weight times height. So that is what I wanted to share with you guys. Now we move on to question B4. Figure B4.1 below shows a pulley which lifts an 8 kg wooden block through a vertical distance of 3 meters by applying an effort of 40 newtons. Then take gravity to be 10 newtons per kg. The first one, calculate the mechanical advantage of the pulley system above. So what's our formula? So we know that mechanical advantage is equal to load over effort. So the effort is here. What's our load? Our load is 8 kg. So what you do if you are given a load in form of mass, so you are supposed to convert mass into weight. So what are we supposed to do? We need to apply the formula for weight. Weight is equal to mass times gravity. So we know that our mass is 8 kg. Then gravity is given 10 newtons per kg. So if multiply, we will see that the weight is 80 newtons. So therefore load is equal to 8 newtons. So for a question like this, if you are given mass, first start by finding weight. Then the weight should later be used as your load. So say 80 newtons divided by 40 newtons. So we can see that if we cancel this, our mechanical advantage will just be 2. It's a ratio, no units must be there. Then for B, if the pulley wheel above has the velocity ratio of 3, what is the efficiency of the pulley? So efficiency is equal to, we have the mechanical advantage over velocity ratio multiplied by 100%. What's our mechanical advantage? We calculated it. It's 2 divided by velocity ratio is given 3 times 100%. So 2 times 100 will give us 200. Then divided by 3, you get 66.6, which is, we'll say 66.7%. This is our efficiency. Then for question C, why is the efficiency calculated in B1 less than 100? Well, the question is, why is efficiency less than 100? So when a machine is operating, it loses energy. The loss of energy can be in form of sound or friction. So as the machine is losing energy, its efficiency is reducing. So say this is because energy is lost in form of, this can be sound and friction, in form of sound and friction as a machine is operating. So as a pulley is operating. So this is indirectly telling us that no machine is 100% efficient. Then we move on to question 5. So 5 is a figure B5.1 below shows a dot representing the position in the center of a rectangular hole where a learner is standing. The width of the hole is 17 meters. Okay. Then when the learner hits a drum, 2 echoes at time intervals, this seconds and this seconds respectively, are heard by the learner after the bang. Assuming that there is no echo from the ceiling, calculate the speed of sound in air. So what are we supposed to do here? What were those 2 echoes? So we know that the echo talks of the bouncing back of sound after hitting a hole or a barrier. So the 2 echoes is, there was an echo in this direction, so the sound moves in this direction, then hits a hole, then from there the sound now came back to this. So that was the first echo. And we can see that the distance from here up to here, we just consider half of 17. So what is half of 17? So this is giving us 8.5. So this means that when this sound moved in this direction, it covers 8.5, and again when coming back it covered another 8.5. Then there is another echo. So this echo moved in this direction, so it hits this hole. Then for this person to hear this echo, the sound must bounce back to this position. Now you can see that the distance, this distance here, if this is our x, then our y, we can see that the distance x in is greater than distance y. So the first echo to be heard by this person was in this y direction, because we can see that the distance is smaller. So we look at the time. So we can see that 8 times 10 to the power negative 3 is greater than 50 times 10 to the power negative 3. So this means that it takes 50 times 10 to the power negative 3 to move in this direction. So this is the time for this. So it's 50 times 10 to the power negative 3 seconds. Then for this one will be 80 times 10 to the power negative 3, since it covers a longer distance. The key point is we can't expect sound to have the same time, given that, let's say these two sounds were moving at the same speed, but we can't expect for time to be lapse of the same. No, since there was a distance, a greater distance must cover a higher time compared to a shorter distance. So that was the concept here. Now we can find the speed for this because we have the distance and the time. So for this one will help us to find the speed. So let's find the speed. So speed is equal to, now for echo it's 2d over t. Why do we need 2? It's we need two distances. One represents the going, then the other one the coming back. That's why for echo speed is equal to 2 times d over time. So it's 2 times the distance we said is 8.5 over the time. The time is 50 multiplied by 10 to the power negative 3. So where is this 8.5 coming from? We said we just want half of this, so it's 80.5. So that's why we are getting that. Now 2 times 8.5 will get back to 17. Now don't confuse that 17. This 17 is the going and the coming over 50 times 10 to the power negative 3. So say 17 divided by 50 exponential to the power negative 3. So I'm getting 340 meters per second. So this was the speed. Now remember, the speed for sound to move in the y direction is equal in the x direction. So the speed was equal. So if the speed here is 340, what was the speed in this direction? Would also be 340. So we can see that we have the speed and we also have the time. So we can find the distance from here up to here. If we are able to find this distance, we can just multiply by 2, then we are able to get this distance here. So that was the concept. So the question is the length of the hole. So what you do, S is equal to 2d is an echo over S over 1, we cross multiply. So it's 2d is equal to S times time. What is the speed? The speed is 340 times the time is 80 times 10 to the power negative 3. So 2d is equal to, so 340 times 80 raised to the power, times 10 raised to the power negative 3. So I'm getting 27.2 meters. So this is our answer. So do not see, no need of dividing by 2, because if we divide by 2, this means that we only find half. We only find half. Then for us to find now the total length, we are going to multiply again by 2. So for a question like this one, we just leave it here, 2d. Can you know that 27.2 divided by 2 is 13.6. So 13.6, this means that the half is 13.6. We'll consider this as the distance. Then the other half will also be 13.6. We'll say this d. So if we do algebra, we'll know that if we say d plus d is equal to 2d. So 13.2 plus 13.2 is equal to 27.2, which is 2d. We move on to question. Figure 6.1 shows a ray of light traveling from water to air. The incident ray makes an angle of 65 degrees with the boundary. Most of the light passes into air is refracted, making an angle of 56 with the boundary. Okay. Then A, complete the ray in figure B6.1 to show the refracted ray. Label the angle of incidence and angle of refraction. So first begin by drawing the normal ray. Remember, the normal ray must be perpendicular to the refracting surface. So this is our normal ray, and the normal ray is always drawn in dotted. Now we can see that the density of water is greater than the density of air, so the ray of light is moving from a more denser medium into a less denser medium. So what will happen to light? Light will bend away from the normal ray. So the angle of incidency will be this angle. The angle of reflection is here. So how can we find the angle of incidence? We know that this angle here is 90. So let's subtract 60 from 90. I mean 65 from 90. So the angle of incidence is 25. This is our angle, 25. Then what else do we have? Let's go back to this. So we can see that making an angle of 56 with the boundary. So the boundary is this one. So here we get 56. So how can we find the angle of reflection? So this will be 90 minus 56. So we have 34 degrees here. So for the first question, we are done. We've labeled the angle of incidence and angle of refraction. Now for B, calculate the refractive index of water. So N is equal to sin I over sin R. So sin I, which is sin 25 over sin refraction angle is 34. So over 34. So let's look at the answer. So we'll say sin 25 divided by sin 34. So I'm getting 0. If I round it off, it's 0.8. Now the refractive index of water is 1.33. Okay, but we are getting this, okay, according to the data that we have. So that's our answer, 0.8. Then we move on to question C. When the angle of incidence in figure B6.1 is increased, total internal reflection will occur. State one condition necessary for total internal reflection. So let's see if we can analyze this phenomenon here. So say the type of arrangement that we have is this one. So this is our incident ray. So if we move the incident ray to the left, we'll reach at a point where the angle of reflection is equal to 90. We call this one as the critical angle. So critical angle is an angle when the angle of reflection is equal to 90. So this is our 90 here. Then what happens if we exceed the critical angle? So if we exceed the critical angle, instead of bending this time, the ray of light will bounce back. So this is what we call total internal reflection. So how and when do we get total internal reflection? This is just when the angle of incidence is greater than the critical angle. So this is when the angle incidence is greater than critical angle. So in a condition like this, so whenever the angle of incidence exceeds or goes beyond the critical angle, then we are going to have this total internal reflection. So that's the condition here. Then we move on to question 7. Table B7.1 below shows the melting and boiling points of lead and oxygen. So lead melting is 327, the boiling is 1744, oxygen negative 219, boiling point negative 183. In what physical state of matter will the first one, lead, be at temperature of 450? Okay, so now let's look at melting. What is melting? So if you look at melting, we define melting as change of state from solid to liquid. Okay, so if the boiling, if the temperature started, let's say from 0, it goes, if the temperature reaches 327 for a lead, then our lead, which is in solid, will start to convert into liquid. So any temperature above 327 will indicate that we are going to have a liquid, because we can see that for boiling, we'll just consider boiling as the change from liquid to gas for a lead. So for it to change from liquid state into gaseous state, the temperature must reach 1744. So now let's analyze this. 327, it is the change from solid to liquid. Then 1744, it is the change from liquid to gas. Now let's look at 450. So 450 is in between these two temperatures. 450 is between these. So if it is between these, then the state of matter for lead is liquid. What of oxygen? We have to do the same. So for oxygen, we can see that we have negative 219. So it starts to melt. So it's at this point the oxygen is in a solid state. Then negative 200 is between this, so we have negative 200. So the temperature is increasing. Then the boiling is negative 183. So it's the same here. Also we have a liquid state. Okay, so we move on to question B. Figure B7.1. Below is a diagram of a metallic hot water storage tank showing how water can be heated using an electric immersion heater at the bottom. Okay. Then water, then cold water inlet, then electric immersion heater. Okay, now let's look at the question. How could the heat loss from the tank be reduced? So the first one, we can make sure that the inside of this container, the surface of this container, we paint it with something that is shiny. So we paint it with something that is shining, so that we may have reflection of heat. So whenever heat is trying to escape this container, the heat energy will be reflected back into the liquid. Thus, the temperature will remain constant in terms of high. So that is the first. So say by painting by painting the surface of the container with a reflecting we can say, or paint, whatever, with a reflecting substance. Then what material would be suitable to be used for the process named in B1? So here we can use a silver material. We know that silver has the ability to reflect heat and light back. We move on to question 8. Figure B8.y below shows a circuit diagram with a lamp connected to a 12 volts battery. So we can see that we have been given the voltage 12 volts, current 0.5, the lamp here. Calculate the charge passing through the battery in 2 minutes. So we want to find the charge. So what is the formula for charge? So the formula for charge is equal to, we need to have current multiplied by time. The symbol for charge is Q, current is I, so the formula is IT. Now whenever you are calculating time, make sure it is in seconds. Now we can see that we have our time in minutes, so there is that need of converting. So we know that 1 minute is equivalent to 60 seconds. So we can see that we have 2 minutes. X we cross multiply. So the concept, whenever you have time in minutes and want to convert to seconds, you just multiply by 60. So 2 times 60 is 120. We have minute times seconds. So if we divide by minute, also by minute, so minute will cancel. So our time in seconds is 120 seconds. So that's what we are going to use. Remember, current is here 0.5 amps times our time is 120. So 0.5 times the number is just half of that number. So 120 times 0.5 is just half, which is 60. So our answer is 60. Remember, the units for charge is coulombs. Then how much energy is transferred by the battery? So how much energy is transferred by the battery? So the formula for energy like this one is energy is equal to voltage times current times time. Now from this formula we can see that IT is just charge. So this formula is also voltage times charge. So what's our voltage? Our voltage we can see it's 12 volts. So we have 12 volts. Then for charge is 60. If let's say if we didn't calculate charge, then we would have used the same, because we know that if we calculate voltage is equal to IT, so we know that voltage is 12, current is 0.5, time is 120. So we know that this will still give us a charge. That's why we are saying we just have to multiply 12 times 60. So I'm getting 720 joules. So that was the energy transferred. So we still get the same, which is 720 as the energy dissipated. Then calculate the resistance of the lamp. So resistance is equal to voltage over current. So what's our voltage? Remember, voltage is 12, current is 0.5. Now here the concept is the same for mathematics. If you are dividing by 0.5, the final answer will be, you just have to double the numerator. So 12 times 2 is 24. So 24 is our answer. So you can just do it by calculator. So this will be 12 divided by 0.5. So you get 24. Then we move on to question 9. So for question 9, during a radioactive decay, thorium with the mass number of 232, the atomic number of 90, emits two beta particles to form a new daughter element whose symbol is U. What is radioactivity? So there are so many definitions of radioactivity. So questions like this depends on the one that you've committed to memory. So we can just say this is just the emission of radiation by a substance. So this is the emission. So the emission of radiation by a substance. Then construct a decay equation to show how thorium 232 decays to U. So emits two beta particles. So let's look at the first emission. So the first emission will have thorium TH 232 90. So what happens to the mass number? Remember, the mass number does not change. The mass number remains the same. Then what happens to the atomic number? Increase by 1. So you add 90 plus 1, we get 91. Then to form a new daughter. So for this one, let's say we have A. Since we are dealing with 2 emission plus C, we write this -1 is 0 here. So this is our first emission. So let's look at the second emission. So for this first emission, we'll say our daughter atom or element is A. So what will happen to the mass number? The same will happen. So the mass number will not change. We'll still get 232. The atomic number, we add another one. So this will be 92. At this point now, we have the uranium as our new element. Then plus this nuclide. So that is what we wanted here. Then determine the number of protons and neutrons in the nucleus of the daughter. So the number of protons is just the number here. So is 92. Then for neutrons, this will be 232 minus 92. So 232 minus 92, we get 140. So 140 is the number of neutrons. So let's hope you are able to understand. So if you are understanding my teachings, I would like to hear from you. You can write in the comment section below. Now let's look at what we can share from section C. So for section C, answer any 2 questions from this section in the answer booklet provided. A car travels along a straight road. The speedometer readings every 5 seconds are shown in table C 1.1 below. So I have time and velocity. Draw a velocity time graph to show the changes of velocity with time. So let me see if I have some space where I can just do the sketching. So we'll say you draw your velocity time graph. So let's look at the numbers. So in the y-axis, we are going to have velocity. Make sure you use the actual graph paper. Then we can see that 0, the highest number is 30. So you can say, you can use the scale of 2 centimeters to represent 5 units. As long as you are able to reach 30, it's okay. But since I don't have enough space, I'll say 2 centimeters represent 10. So if this is 0, here I get 10. Then I have 20. Then here we have 30. Then for x-axis, I'll say 2 centimeters to represent 5, as long as I'm able to reach 40. So we'll say 5, 10, 15, 20, 25, 30, 35, 40. So this is, we know it's time in seconds. So let's look at the first one. The first one is 0,0. The second one is 5,10. So 5,10 is here. The second one is 10, that's 10,20 here. The third one, 15,30 here. Then 20,30 here. You can see that here the velocity is constant. Then 25,30, so it's here. Then 30,30, it's here. 35,15, so 35,15 is somewhere here. Then 40,0 is here. So the graph for you, if you are using the actual graph paper, I'm expecting to have straight lines. So straight lines here. So this is the first question. That is how you are supposed to do. Then for B, using your graph, determine the distance covered after 20 seconds. So after 20 seconds. So 20 seconds is here. So let's analyze what shape are we getting. So this is a trapezium. It's like this. So from here up to here is 20. This is our B. Then here, this is our height. Height is from this point up to here, which is 30. Then our A is this one. So A will be from here up to here. B will be from this up to here. Then H is this distance up to this. So let's look at the formula. So distance is equal to half A plus B multiplied by H. So half, what's our A? So A, let's move here. So we can see that the difference between 20 and 15 is 5 is our A. Plus C, the B is from 0 up to 20, that is 20. Our height is 30. So 20 plus 5 is 25. Half of 30 is 15. Then 25 times 15. I'm getting 375 meters. So that is our distance. Then for Roman number 2, total distance traveled by the car. So total distance will be, distance is equal to half, it is also a trapezium, then times this. So we'll have half our A. This time our A is this one here. So our A, if we move 15, also here 30. 30 minus 15, so our A is 15, plus our B is just this 40. So 40, our height is still 30. So 40 plus 15 will give us 55. Half of 30 is 15. So 55 times 15. So I'm getting 825 meters. Then Roman number 3, average velocity of the car for the whole journey. So average will be is equal to total distance over total time taken. So what's our total distance? 825 over total time is 40. So what is that? So what is the average velocity? So average velocity will be 40. So 825 divided by 40. So I'm getting 20.6 meters per second. Okay, so now let's move on to question C2 figure C. 2.1 below is a diagram showing a mercury thermometer placed in warm water. The reading shown on the thermometer is 50 degrees Celsius. Then let's go to the first question. Define thermal expansion. So thermal expansion, we can say, is the process of particles in a substance moving further. So moving further apart. The whole thing is about to expand is to become larger in size. So moving further apart because they have been heated. So this is one way in which we can define thermal expansion. Then for Roman number 1, what is the temperature shown on the mercury thermometer in Kelvin? So we have the temperature in degrees Celsius. So what is the temperature in Kelvin? Temperature in Kelvin is temperature in degrees Celsius plus 273. So this is 50 plus 273. So what is 50 plus 273? I'm getting 323 Kelvin as my answer. So whenever you are trying to convert from degrees to Kelvin, you just add the given in degrees plus 273. Then what property makes it possible for the thermometer to measure temperature? What property makes it possible for the thermometer to measure temperature? So like the property here is, we can say, high sensitivity to a change in temperature. So high sensitivity, so this can be like which thermometer are we looking at here? So presence of mercury. You know that mercury respond quickly to change in temperature. So high sensitivity. So we say high sensitivity. So what can make a thermometer to be of this? So you can see thin glass wall. Glassy, or also presence of a bulb also can also work there. Then give N2 advantages of using mercury in the thermometer over alcohol. The first one, mercury does not wet the glass. Then the other one, mercury is easy to see. Is easy to see through the glass. Also, in terms of sensitivity, mercury responds faster than alcohol. Then we move on to question C. The difference between the ice point and the steam point in a liquid in glass thermometer is 30 centimeters. What temperature is recorded when the mercury thread is 30 centimeters above the ice point? So say temperature in degrees Celsius is equal to x over y multiplied by 100 degrees Celsius. So what's our x is 10 centimeters over the difference here is 30 centimeters multiplied by 100 degrees Celsius. So centimeter cancels this. So what is 1 over 3 of 100? So what is 1/3 of 100? So I'm getting 33.3 degrees Celsius. So that's our temperature. Then state 1 thermometer that can be used to measure high temperatures that vary considerably. So this is a thermocouple. So it's a thermocouple thermometer. This one can measure a very high temperature. Name a device that uses the thermal expansion to control temperature in a pressing iron. So it is thermostat. Okay, we move on to question 3, the last one. So a Giga counter or a Geiger counter was used to measure the activity in countless per minute from a radioactive sample in the laboratory over a period of years. Over this period, the background radiation was regularly measured at 4 counts per minute. The table of results is shown below. So time in years 0, 1, 2 up to 6, recorded activity in countlets, then activity due to sample alone. So here we have been given the background radiation of this. So copy in your answer booklet and complete the table giving the activities of the sample. So how do we find the activity due to the sample? So whenever you are given this background radiation, you're supposed to subtract this number from the recorded activity. So it's for us to get this number, you subtract 124. So 124 minus the background, which is 4, minus 4, you get 120. So you go to 80. 80 minus we'll be subtracting the background radiation. So that's a formula. You subtract the background radiation. So this will give us 76. Then 52 minus 4 give us 48 here. Then 34 minus 4 give us 30. So you've gotten the point. 23 minus 4 will give us 19. 16 minus 4 will give us 12. Then 12 minus 4 we have 8. So that's what you are supposed to do. So that is the concept behind it. Or maybe if you are to encounter a question like this one, whenever you are given recorded activity in counts per minute and you are given background radiation, for you to find the activity due to sample alone, easy. You subtract the background radiation from the recorded activity. You'll be able to get activity due to sample alone. Remember number 2, what is background radiation? So this can be defined as this is a small amount of radiation. A small amount of radiation present on Earth at all times. At all times. So this means that at all times on Earth, in the atmosphere, there is a small amount of radiation that is just there. Now we are lucky that it is just in a small amount. So that is what we call a background radiation. Now give 2 possible sources of background radiations. We have the first one, we have radon gas from the Earth. So radon gas can be the production of this. Then also cosmic rays. Even explosions may also produce that. Then on a graph paper, plot a graph of the values of the activity of the sample against the time. The activity of the sample. So we can let's do what we can do. So first let's look at the numbers. So we are starting from 120 up to 80, then times 0 up to 6. So let me see what I can do. Okay, for this one we have at least enough space. Okay, so we'll draw the y-axis. So in x-axis we'll say 2 centimeters represent 1, 2, 3, 4, 5, 6. Then we have time in years. Then for y-axis, what are we supposed to do? So the highest number is 120. So we'll say 2 centimeters. 2 centimeters represent, let's say, we'll say 20, 40, 60, 80, 100, then 120. So we have, in y-axis we have activity due to sample alone. So the first one is 0,20, 0,20, I mean 120 is here. The second one, it's 1,76. So where is 1,76? So 1,76 is somewhere here. Then what else? 2,48, 2,48, 2,48, somewhere here. 3,30, 3,30, 3,30 is here. 4,19, 4,19, so 19 somewhere here, just below 20. That should be somewhere here, so 19 is here. 5,12, 12 would be somewhere here. 6,8, okay, 6,8, so somewhere here. So you can see the graph of this. So this is how the graph of the decay curve is. So you can see that at the beginning, we have the total amount of a substance is greater, because after sometimes we are expecting that number to be dropping by half. So that whenever a substance is undergoing a decay, the mass or the size of that reduces. Then it determines the half-life. So how can we find the half-life? So say half of the original, which is 120. So you look at the last number for in y-axis where the curve is meeting the y-axis, so which is 60. So after finding 60, we need to go where there is 60. So we draw a dotted line parallel to the x-axis. Then we need to drop. I'm sure for me this should be somewhere here. So the point at which you are touching the x-axis is your final answer. I'm sure this should be 1.2 years. So this is our answer. So this is what we can share for this paper. Thanks for watching.